Let's delve into a new content area and talk about the assumption of homoskedasticity in a moderated multiple regression context. So there are two types now of homoskedasticity that we have to check for when we are running an MMR. The first one is type 1. And this is the same as we've been talking about before in the regular regression case, and that is that the residuals are equally diffused around the best fitting line across all levels of the predictor. So in an MMR, we're going to take all of our subgroups and we're going to have an aggregated sample, and that's what type 1 homoskedasticity indicates, are those residuals constant across all levels of predictor in the full sample, the total n size. Okay, so that's no different than we've had before, but now it's called type 1 because we have another type that we need to check for in MMR, and that is type 2. And that means that the residuals have to be equally diffused around the best fitting line inside the subgroups. So if the residuals are close to the best fitting line in the first group, for males, for example, they should also be close to the best fitting line in subgroup 2. Similarly, if they're diffused around the line quite a bit, which means the relationship is not as strong, remember, they should be about the same, to the same extent, diffused around the line in the other subgroup. And so a Guinness in your text, page 46 and 47, has graphs that depict both types of heteroskedasticity and talking about the difference between them. So just a quick note, again, type 1 applies to all regression analyses, both moderated regression and regular regression, whereas type 2 is a very special case that only is an issue in a case where we have a categorical predictor interacting somehow with a continuous one. So only in this special case does type 2 apply.